Good morning students. So this is physics chapter number 3 lecture 2, and in this lecture we'll be doing the NCERT solutions of the questions that I gave you in the last lecture. Okay, so the first question says the storage battery of a car has an EMF of 12 volt. If the internal resistance of the battery is 0.4 ohms, what is the maximum current that can be drawn from the battery? So EMF is given to be 12 volts. Resistance is given to be 0.4 ohm. Now it is asking what is the maximum current. Now to calculate maximum current, we'll use Ohm's law. You know V is equals to IR by Ohm's law. So I will be equal to V by R or E by R. Now I have written here I maximum. I is maximum because E is the maximum potential difference, because as I told you in the theory lecture that EMF is the maximum voltage. So I maximum will be E by R. By putting the values, you'll get the answer 30 ampere. Okay. So the next question is, okay, so this is the second question. A battery of EMF 10 volt and internal resistance 3 ohm is connected to a resistor. So as you can see in this diagram, a battery is there of EMF 10 volt, resistance 3 ohm is connected across a resistor capital R. Now the question says if the current in the circuit is 0.5 ampere, that is I is given to be 0.5 amperes, what is the resistance of the resistor? Okay, so now we want to calculate this capital R. Okay, now as you can see in the circuit, this small r and this capital R are in series because the current will go from the one path only. So now E is given to be 10 volt, internal resistance is given to be 3 ohms. So current in the circuit will be equal to I is equal to E upon total R. Total R is equals to capital R plus small r because they are in series. Okay, so from this equation we can calculate capital R. So R plus R will be equal to E upon I. By putting the values, you'll get it as 20 ohm, and therefore capital R will be 20 minus 3, which will be 17 ohms. So this is the value of the resistance which we want to calculate. Now the second part of the question says, what is the terminal voltage of the battery when the circuit is closed? Now we want to calculate terminal voltage. As you know the formula of voltage, V is equals to IR. So I is given in the question, R we have just calculated 17 ohms. So put the value of I and R. So you will get terminal voltage is equal to 0.5 into 17, that is equals to 8.5 volt. So I hope it is clear. So the next question is, okay, so question number 3. It has two parts. The first part says 3 resistors 1 ohm, 2 ohm and 3 ohm are connected in series. What is the total resistance of the combination? I think this is a very easy question and all of must have done it. So the total resistance will be equal to 1 plus 2 plus 3 is equals to 6 ohms because this is the formula in series only. Okay. So the second part says if the combination is connected to a battery of EMF 12 volt and negligible internal resistance, obtain the potential drop across each resistor. Now, as all the resistances are connected in series, the current across all the resistors will remain same, but the potential will be different. So to calculate potential, we'll calculate what is the value of I first. So as you know, the formula of I is E by R. E is given to be 12 volt and total resistance is 6 ohm as we have calculated in A part. So I will be equal to 2 ampere. Now we have to calculate voltage across each resistor. So V1 will be equal to I1 R1, or you can say I R1 because I will remain same only. So I is 2, R1 is 1 ohm, so it will give you 2 volt. Similarly, V2 will be equal to I, that is 2 into R2, that is 2. So therefore it will be 4 volt, and similarly V3 will come to be 6 volts. Okay. So now the next question. Okay, the question number 4. It also has two parts. First part says 3 resistors of 2 ohm, 4 ohm and 5 ohm are combined in parallel. What is the total resistance of the combination? Again, this is very simple. You just have to apply the formula 1 upon Rp is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Putting the values, you'll get the value of equivalent resistance, that will be 20 upon 19 ohms. Okay. So the second part. If the combination is connected to a battery of EMF 20 volt and negligible internal resistance, determine the current through each resistor and the total current drawn from the battery. Now because this is a parallel combination, potential across each resistor will remain same, that is 20 volt, which is given in the question only. Okay, so this is very simple. You just have to calculate I1, I2 and I3. So I1 will be equal to V upon R1, that is 20 upon 2 ohms, that will be 10 ampere. Similarly, I2 will be V upon R2. It will give you 5 ampere. And similarly, I3 is V upon R3. It will give you 4 amperes. So the total current in the circuit will be addition of this, that is 10 plus 5 plus 4, which will be equal to 19 amperes. Okay, so the next question is question number 20. It has 3 parts, A, B and C. So first of all, I'll be discussing A part. So it says, given n resistors, each of resistance R, how will you combine them to get the maximum and minimum effective resistance? And what is the ratio of the maximum to minimum resistance? So first of all, it is asking how will you combine the n resistors to get maximum resistance. As you know, in series combination, we just add the value of resistances. So in series combination, the value of equivalent resistance will be maximum. So to get maximum resistance, they will be connected in series. So Rs will be equal to R1 plus R2 plus R3. It will go up to Rn. So as you know, if and in question each resistance is given to be same, so the total will be equal to, hence maximum resistance will come to be NR. Okay, so now in parallel combination, first of all, in second part it is asking what is the minimum effective resistance. Now minimum will be in parallel combination. Always remember this. If you want maximum resistance, you will connect the resistances in series combination, and if you want the minimum resistance, you will connect the resistances in parallel combination. So again, now in parallel, you know the formula, 1 upon Rp is 1 upon R1 plus 1 upon R2, and here we'll go on. So from here, the minimum resistance will come to be R by N, because this will give you N by R. So Rp will be equal to R by N, and the ratio will be equal to Nr upon R by N, that is Rs upon Rp, which will be equal to N square. So this is how you have to calculate if you want maximum or minimum resistance. Okay. So the second part says, given the resistances of 1 ohm, 2 ohm, 3 ohm, how will you combine them to get an equivalent resistance of first 11 by 3 ohm? So to get this of resistance, you just have to think many pairs. Okay, so if I combine 1 and 2 in parallel, and I combine this combination with 3 ohms in series, I will be getting 11 by 3 ohm, because 1 and 2 are in parallel. So using the formula of parallel resistance, 2 into 1 upon 2 plus 1, that is R1 R2 upon R1 plus R2. This is the formula in parallel combination, plus 3 is in series with it, so plus 3. So it will give you 11 by 3 ohms. Second option, it is saying 11 by 5 ohms. So to get 11 by 5 ohm, 2 and 3 are connected in parallel, and 1 ohm is connected in series with the combination. So again, using the formula for 2 and 3 in parallel and 1 in series, you will get 11 by 5 ohm. Third is 6 ohm. So simple, if you connect 3 ohms, 2 ohms and 1 ohm in series, you will get 6 ohms. That is 3 plus 2 plus 1, that will be equal to 6 ohm. Okay. So the next it is saying 6 by 11 ohms, fourth part. So to get 6 by 11 ohms, all the resistances are simply connected in parallel. 1, 2 and 3 are connected in parallel. So when you use the formula, you will get 6 by 11 ohm. So students, always remember to do such questions. First of all, calculate if you connect all the resistances in series, what you will get, and then calculate if you connect all the resistances in parallel, what you will get. After that, make different combinations by taking 2 resistances in parallel, another one in series. Okay. So the next part is determine the equivalent resistance of the networks shown here. So we'll be discussing A part here. So A part. Okay. So now look carefully. You can see in this diagram, this 1 ohm, suppose current I is coming from here. It will go in this side and it will go in this side. So for 1 ohm and 1 ohm, these two value of current will be same. That means 1 ohm and this 1 ohm are in series. Similarly, this 2 ohm and 2 ohm are also in series. So basically, I have redrawn the diagram here because 1 plus 1 will be 2 ohm. So 2 ohm. Similarly, 2 plus 2 will be 4 ohm, 4 ohm. So if we proceed, there are 4 such networks. So we will get 4 such networks here by 2 ohm and 4 ohm by calculating them in series. Okay. So now as you can clearly see in this diagram, 2 and 4 are in parallel because both the ends are connected. So again, if you calculate the formula by using the formula in parallel combination for 2 and 4, that is R1 R2 upon R1 plus R2, you will get 4 by 3 ohm for each of these 4 networks. So now again redrawing the diagram, all these 4 resistances of 4 by 3 ohm are now connected in series. So just using the formula of series, 4 by 3 into 4, you will get 16 by 3 ohms. I hope it is clear. I have just redrawn the diagrams to make it easier to understand. Okay, so always proceed like this only. I hope it is clear. Okay, so the B part. In B part, it is very simple. I hope every one of you must have solved it. You can see the current will be following one path only. Yes, so that means all these resistances are in series. So just add them, you will get 5R. Okay, so the next question is question number 21. It says, determine the current drawn from a 12 volt supply with internal resistance 0.5 ohm by the infinite network shown in the figure. Each resistance has 1 ohm resistance. Okay, so now look carefully in this diagram. It is given to be infinite. Okay, this circuit is given to be infinite. Now, if I see clearly, see these 3 resistances of 1 ohm. Let us suppose this is one circuit of 3 resistances. Again in this circuit, such similar combination is connected of 3 resistances. Again 3 resistance combination is connected. So we can say this circuit is made infinite by connecting many circuits of these 3 1 ohm resistances. Okay, so I am repeating once again, this circuit is made infinite by connecting many circuits of this type of 3 1 ohm resistances. Okay, so now let us suppose the equivalent resistance of this circuit is X overall. Okay, so now because the circuit is infinite, if I add one such circuit of 3 1 ohm resistances, this, or I remove one circuit of this type, it doesn't matter because the circuit is infinite. Okay, so now look here in this diagram. X I have assumed to be total internal resistance of this circuit. Now what I am doing, I am just adding the such a combination of 3 1 ohm resistances with this X. Remember, it does not matter either you add this such type of circuit of 3 1 ohm resistances or remove it, because circuit is given to be infinite. Okay, so now what we will do, we will be using this circuit only, and we'll be calculating equivalent resistance. Okay, so now as you can see clearly, X and this 1 ohm are in parallel. So for this we'll be using the formula of parallel combination, which is R1 R2 upon R1 plus R2, that is X into 1X upon 1 plus X, R1 R2 upon R1 plus R2. Okay, so we have calculated this. Now this 1 ohm and the combination of these two are connected in series. In series, the formula is R1 plus R2 plus R3. So R1 is this only, plus R2, that is 1, plus R3, that is also 1. So this will be the equivalent resistance of this circuit, and we have assumed it to be X only. So again, this whole equation or this whole internal resistance will be equal to X only. So now this will form a quadratic equation. When you will solve it, you will get the value of X as 1 plus minus root 3. Okay, now if I consider negative sign, the value of X will come to be negative. But as you know, resistance can never be negative. So we'll be not considering negative sign here. We'll only assume X to be 1 plus root 3. So putting the value of root 3 as 1.73, you will get the value of X to be 2.73 ohms. Now total resistance, to calculate total resistance, we have to consider this 0.5 ohm also. Okay, because this is in the question, it is given the internal resistance is 0.5 ohm. So to calculate total resistance of the circuit, it will come to be 2.73 ohms plus 0.5 ohms. So total it will be 3.23 ohms. Okay, so now in this question, current is also asked, the total current. So to calculate total current, we'll be using Ohm's law, which will be equal to I is equals to V upon R. V is given to be 12 volt in the question, and total resistance we have calculated to be 3.23 ohms. So by putting these values, we will get total current in the circuit as 3.72 amperes. Okay, I hope this is clear. In the next lecture, we'll be studying about Kirchhoff's law. I'll tell you how to make the equations using Kirchhoff's law and how to solve them. Okay, thank you.